I can't believe I just learned something. Are you surprised that you learned something on this stream? Is this not the most knowledgeable stream that you have been on? I outrank every other person on this list of software and game dev. Are you kidding me? No, I'm just kidding. All right, so we're going through part 2 of Freecodecamp. I think we finished at 21%, and we're just gonna keep going until our time's up and we get a little tired and need a break. So here we go.
And loop idioms are patterns that have to do with how we construct loops. We have the mechanics of fors and whiles, but ultimately we want to get something done. We want to solve a problem with a loop. And often what we have to do is, if we have a set of things, whether it's lines or strings or characters or numbers, we're looking for something like the largest or the smallest, or we want to add them up or something like that. And so we can't just say up, we have to say go through each one and do something to each one and somehow achieve adding them up. And the pattern that we're going to follow is we're going to have this loop that's going to do run once for each thing, right, in some data. And then we're going to set something at the beginning, and then we're going to do something to each one. And at the end, we're going to kind of get the payoff. We're going to get the result. So if we're doing sort of summing things, we're going to have a running total. And so this will be like t equals 0. And then this will be t equals t plus the thing value. And then, but this is not the real total. It's the running total during the loop. But at the end, it is the real total. And so we're going to look at what you do before the loop starts, during the loop, and then what you get after the loop and how you can use that. So we're going to use this loop. It's just going to loop through a set of 6 numbers over and over again, right? So we're going to do something before the loop, we're going to do something after the loop, and then we're going to run the loop some number of times. And in this case, thing is our iteration variable because I'm using unmnemonic variables now. So it's going to run 9, 41, 12, 3, 74, and 15. So it's going to run and print these things out. So it runs this loop 6 times, and away we go. Now this loop does nothing except print stuff out. Of course, I like to do that first, is always print things out to make sure that sort of my brain is functioning. So to kind of understand how these loops work, I'm going to ask you to function as a program. And I'm going to show you some numbers in succession, and I want you to mentally figure out what the largest number is, but more importantly, think about how your brain is solving this problem of what is the largest number. Given that I'm only going to show them to you one at a time for a little while, and your brain has to do something. Imagine I was going to show you thousands of numbers. I'm not, but imagine I was. How would you organize yourself in a way so that for like an hour and a half, you could sit here as I showed you numbers and you keep track of the largest number that you've seen of all the numbers? Okay, so here we go. Here's your first number, second number, third number, fourth number, sixth, and last number. What was the largest number? What was it? It wasn't too hard. It was 74. But that's not the question.
Let's go.
How did your brain arrive at 74? So here's all the numbers. If I've shown you all the numbers,
Because we looped through the whole list.
Would sort of fluidly wherever it felt like moving and then arrive at it. And probably what it would do is it would do something like kind of move like this, find this, and then sort of check to make sure that it's okay, and then say like, okay, I got 74, I'm done. That's not how computers do it. That is not how computers do it. They do not move fluidly. But they are highly dedicated. They're going to do something.
I feel like we all get the sense of looping. We did this last time where obviously we have this little list right here, and 3, 41, 12, 9, 74, 15 are all items within this little array, and we just want to loop through every single one, and then inside of this for loop, we want to do something to it, right? So below is code to find the smallest value from a list of values. One line has an error that will cause the code to not work as expected. Which line is it? Smallest equals none. Print before and smallest. For iter variable and 3. If smallest is none or iter var is less than smallest, which line is going to break it? So our options is 3. That's not going to break anything. 4, like leaning on this. 6 is, or 7. Huh. I'm leaning towards 4. Let's just see what happens. Because this isn't going to, this does run if it is none. I would imagine then 6, actually, because we're breaking out of this. You say it's 3 for you? Let's try it. Nope, that's not right. Okay, let's go to 6. I think it's 6. Okay. All right. So I was right at first. 6 because we're breaking out of it. So we're not really doing this part of the for loop, right? Because we're breaking before we even get to it. This conditional checks out, but we're breaking. So it doesn't actually like work. Like we're not actually doing anything in this for loop because it's always going to be true and we're always breaking. So even on the first iteration, it would just break out of the loop. How is smallest not none though? But that's the thing. Smallest will always be none. It never changes. I mean, it changes off that first iteration, but we already broke the loop. It says smallest is none in the first iteration, yes, but then we break. I don't think it with the break. We never go back into the loop, right? After the first iteration? I mean, either way, we always break. All right. Which of these evaluates to false? Oh, okay. Let's watch the video.
So now we're going to look at some more patterns of the different things we can do at the top of the loop, in the middle of the loop, and at the bottom of the loop. And the first one we're going to do is counting. Now we're going to take a look at the number of something, the number of things in our list. Now we could just inspect it and see 6, but you will have for loops like you're reading through a file or scanning through some data. And so the notion of counting, you have to assume that you don't really know that there's going to be a lot more than just 6. But for now, we're just going to do 6. And we're going to count how many things that we see in this loop. And the pattern is simple. You set a variable, zork, to 0 at the beginning. We often call this variable count in mnemonic. And now we're going to run this loop 6 times. 1, 2, 3, 4, 5, 6. And each time we're just going to add 1 to zork. So zork starts at 0, then it goes 1, 2, 3, 4, 5, 6. And we're going to print it out. So when we see the now 16, when we see the 15, 4 stops afterwards. And this is 6 is then the ultimate count that we got. So that's very simple. The pattern is that set it to 0 at the beginning, add 1 to it. And if you run that enough times, then this is how many times that happened. And in a sense, it's how many times this line ran, right? Sometimes you put this in an if statement, et cetera, et cetera, et cetera. Okay? Oops. Now we can do the same thing to get a total. The way the total works is you compute a running total of the number of the items that you've seen so far. And at the end, the running total in effect becomes the total. A better variable name for this would be like sum or total or something. Zork, I'll use zork again. So you set zork to 0 and it starts out the total we've seen so far is indeed 0. And then we're going to run this 1, 2, 3, 4, 5, 6 times, and thing is going to be the iteration variable to take on the successive values. And each time through, we're just going to take our running total and add to it the thing we've seen. So we see 9, and the running total is 9. We see 41, and the running total becomes 3. We get a 3. It becomes 65. We get 74. And the running total is 139. How many more? How many more are we going to see? We don't know. It could be a million. Could be 1. Oh, it's only 1. We get a 15. Our running total is 154. And what's true at any moment here is the what we've seen so far. Now, when we're done, the for loop quits for us, and afterwards, 154 is indeed the total. So the running total while we're in the loop, at the end of the loop, after the end of the loop, we have the actual total. So it's not very difficult to convert this to the average because we calculated the count and we calculated the running total, and now we're going to have the average by simply dividing those. Okay. So now this time I've used mnemonic variables. Don't get confused by this. Mnemonic variables are just friendly names I chose for you to read the code easier. I am not communicating Python in any way by naming this count and sum, but count and sum is nice. Okay. So I set count to 0 and sum to 0. I set count to 0 and sum to 0 at the beginning, and the count is 0 and sum is 0. And then I'm going to run this loop 6 times. 1, 2, 3, 4, 5, 6. And each time value is the iteration variable. I count every time I run the loop. I count equals count plus 1, sum equals sum plus value. So I have a running count and a running total, and they show up here 1, 2, 3, 4, 5, 6, and then the running total. And then at some point the for loop, we do the last one, and the for jumps out, and it divides 654 is the count and running total, and then it divides the average sum over count. Okay. So that's just again a pattern of something in the beginning, something in the middle, something in the end. Another kind of thing we tend to do in loops is we look for things, we hunt for things, and so this is where we have an if statement inside of a loop. And of course, I've created a silly simple thing.
The way he's like looping through all these different ways of using a loop, it gives a good example of the different things you can do, even things I haven't done before. So this is actually really nice for those of us that are learning Python to begin with, or are just like catching up on things that we may not have learned before. So this is actually really good.
In this code, I am looking for large values that are greater than 20. And again, don't think of this as just 6 numbers, but I'm looking for all the values and I'm going to print them out. It says before, it's going to run this 9. Well, if 9 is greater than 20, it's false, so it goes back up. 41, true, so it prints out 41, then goes back up. 12, false, goes back up. 3, false, goes back up. 74, true, so it runs this, so out comes that little print statement, goes back up. And then 15 is the last one, and that's false. It goes back up, and the for says we're done, and then we do afterwards. And so this is just the notion of having an if statement inside of a for loop, where we're sort of picking or choosing or selecting or looking for something in a large set of things that we're looping through. We can also say, I want to know if a particular value is there. And so we're going to use a Boolean variable. And we've talked about integer variables like 1, 42, and then floating point variables like 98.6, and then string variables like hello world that have quotes in them. This is a fourth type kind of variable. It's called a Boolean variable, and it only has 2 values. It has true and false. Matter of fact, these if statements, they return Boolean values. Value equal 3. That is returning a true or a false based on the value of value. There's a mnemonic confusion there, right? What I'm using. So I'm going to make a variable called found, and that's a decent name for a variable, so don't get hung up on that. And I'm going to initially say found is going to indicate to me whether or not I found a 3 in my list. And I'm going to start before the loop starts. It's say false because we haven't found anything yet. So found equals false. And so at the beginning of the loop, found is false. Before the loop starts, found is false. And now we're going to run this loop a bunch of times. 9, is that true? No, skip. 41, is that true? 12, skip. Right? So 9, 41, 12. And found has remained false because we haven't done anything to it. But now in comes a 3, and this becomes true. So it runs this code. So found becomes true, and then we print it, and you'll notice that when we see a 3, we get true. And then it runs again. We get 74, it's still false. 15, it's still false. Unquit. And the residual afterwards is true. And in fact, if you didn't know any of this and you don't print that out, all you know is that afterwards we loop through all those things, and we know that there was a 3 in there. That's what we're doing. So we search all of them, we check for 3s when we found a 3, and you can see basically that the found remains false until it flips to true, but then there's nothing to set it back to false. There's nothing in this loop that's going to set it back to false. So once it sort of catches the 3, then it remains true for the rest of the loop, and then it just finds its way out. Now, if you want to think about it for a moment, ask yourself, how might we make this loop more efficient by putting a statement right in here? Think about a way to, once you found it and it's true, there is sort of no reason to keep on going. So what would you put there to perhaps make this loop to look for 3s, just to tell you whether or not there was at least one 3 in there, how to make that more efficient? Just think about that. Okay, so now let's look back at the largest value that we started out with, right?
I mean, these are just different ways of going through a loop.
I'll give you a second to look at it, pause if you need. It's not going to fix it. It's not going to find our smallest number. -1, do anything, and we claim that afterwards the smallest we've seen so far is -1. And that is because, of course, -1 is smaller than any of the numbers that we saw.
Or which of these evaluates to false? 0 is not 0.0, 0 is 0.0, 0 equals 0.0. I would probably say this. Let's try it. No? Oh, interesting. It was B. Very good. Okay. I wonder why though. I'm guessing they're typing it by like int and float, because these aren't exactly the same. I guess it's a trippy one. It is a trippy one. Yeah, I think it's a type thing. So it does make sense, right? So 0 int 0.0 is a float. So these aren't exact. If we say is, maybe this is where it strictly types specifically the type. So maybe that's what it did. Okay, now we go through strings in Python. What will be the following code print for n in banana? Print n. What? I'd imagine it would loop through this. I think it's D, but let's look through this.
Hello and welcome to chapter 6. In this chapter, we're going to talk about strings. And chapter 7 is the payoff chapter. So up to this point, we're still learning sort of basic building blocks. And actually, we're going to write a real program in chapter 7. So just learn this, and the payoff's in chapter 7. So we actually been using strings from the very first lecture, because if you print hello world, well, that's a string. And so we've been doing things. This little slide here is all review. Plus we can concatenate strings. We can sprint to print them out. Print's just a function. It takes as a parameter something, strings, etc. We can put digits in strings, but we can't add to them. By now, you figured this out, but you can use things like ints to convert the strings to integers and then print things out. So, we've been doing this for a while. We've been talking about strings all along. Now today, what we're going to do is going to just get into strings in more detail. We're reading input data with the input function. Input returns us a string, and if we want to input a number, we have to run some kind of conversion, like we have to do before we take this data that we read from input. And so there's things that we've got to do, and we've been doing all these things in programs so far. But if we look in a little more detail inside strings, we can index within strings each character. So each character has a separate position and a separate index. And they basically, the letters have positions, and the positions start at 0. And the best way I explain this to remember this is it's the elevators, as we used in one of our examples a long time ago. Elevators in Europe start at 0, and so strings start at 0 as well. Turns out in the old days there's some efficiency with the notion of lists of things starting with 0. These days the efficiency isn't the issue, but there's a certain elegance starting at 0, even though intellectually you might think 1 would be the first character in the string. Might make most sense to be sub 1, but it's not, it's sub 0. But just remember that. And so we have this operator called the index operator, and it's square brackets. Fruit is a variable that contains the string banana, and then fruit sub 1 is the character that's in position 1. Now that actually is the second character.
Okay, so then I changed my answer. I think I changed my answer. I don't think it's going to be D. I actually think it's going to be this. I think it's going to be C. I don't know it anymore.
I'll keep reminding you until I get tired of reminding you. So that assigns A, the letter A, into the variable letter. Of course, that's a badly choice. And the thing that goes inside this can either be a constant or it can be an expression. So this is x equals 3, and then fruit sub x minus 1, well, that means 2, which is position 2, which is an n, and so that gives us an n. So the index is an operator, and you can add this bracket syntax to the end of a string variable. You can't index beyond the length of the string. So if I say zot sub 5, well, there's only 3 characters, which means 0, 1, 2, but sub 5 doesn't work. And of course, we get a happy little trace back. So you have to be careful when you're starting to pull stuff out of strings. So some of the things allow it, some of them don't, and you'll kind of get used to that. We can ask how long a string is, and so we use the len function. We pass the string variable, and we pass it into len as parameter, and len gives us back the length of the string, not the position. So it's 0 through len minus 1. So it's 0 through length minus 1. So length is just another function that we've been doing functions now for a while. You pass in a parameter, and then len does some work, and out comes 6, and that goes back into x, because the function has a residual value. It just happens to be a built-in function. And somewhere deep inside Python, there is code that takes this, and somebody wrote a loop or looked something up, and then returned a return value and sent back a 6 to go into our. And so function is there, and like I said, we've been using this for a while. Another thing we tend to do is to look through strings and look at strings and dig data out of strings. Python is excellent for doing sort of these kinds of lookups. And so we can write a simple loop. We can write a for loop that creates some kind of a iteration variable like index. And given that we know that these positions are 0 through 5, we can set this to be 0, and then write a while loop while the iteration variable is less than.
See, I think even with the while loop, you see that index is that little variable here that we use, or the iterator. So if we're printing n in banana, for n, I still think it's going to be C. I don't think it's actually going to print the actual strings. I think it's going to be the actual index of each one, but I could be wrong. I absolutely could be wrong, because we're not saying, or we'd have to set banana to a variable, and then we would say like print whatever variable name index n.
The length of fruit, and remember this is 6, so it's going to be 0 through 5. 0 through 5 are the values we want to generate, and then we can look up one at a time, pull out fruits of index, so fruits of 0, fruits of 1, 2, 3, 4, 5, and then print out the position and letter index, and then n.
Yeah, so that n is what it's making me switch back to D, because the n, we're looking into this string, so I'm assuming we'd get access to the individual characters.
Add 1 to index, and it runs, so 6 times, 0 through 5, and out we go to produce this output right here. And so that's one way of looping through strings. That is a basic indeterminate loop, but we construct carefully an iteration value. That just says letter is our iteration variable, and it's going to take on the successive values of each of the characters. So this loop is going to run 6 times, and letter is going to be B, A, and A.
This kind of confirms it. I think D.
I'm always terrified when I make these slides. I'm going to misspell banana, because somehow I always think that there are 2 N's somewhere. I don't know. It's not one of my favorite words to spell. I actually didn't choose banana as the constant. They sort of both do the same thing. They both just print the letters out.
Okay, so let's go with D and C. Yeah, it was D. Very good, chat. Very good. Yeah, that N is what kind of changed it for everyone, right? What is the value of I in the following code? I equals word dot find NA.
So now we're going to dig into strings a bit, and we've already looked at how you can pull out a single character in a string, and now we're going to look at what we call slicing, and that is pulling chunks of a string out. And again, we're just going to use the square bracket operator, and S. The way I say it is sub.
You guys think true? All right, let's see.
S sub 0 through 4. So I look at the class through, I look at the brackets as sub. And so S sub 0 through 4 says start at position 0, and then go up through, but not including 4, right? So we don't include 4. So that's probably the hardest part of this. Up to, but not including. Up to, but not including. This seems counterintuitive, kind of like.
Oh yeah, that's a little confusing. The slicing strings part. So we start at 0, so we do include 0, or the index is 0, but we don't include 4, but even though we specify it, like that could be.
Starting at 0 seems counterintuitive, but after a while, you'll kind of get used to it, and there'll be situations where you're writing code like, oh, that's why that works better. But just for now, remember it. Up to, but not including. It's just kind of a little thing. We'll come back to when that is useful for us. 6 through 7 ends up being starting at 6, up to, but not including 7. So that's why we only get the P out. Now, one thing that Python is pretty nice about is it's not going to give you a trace back. We might expect that 6 through 20, well, there's no 20 characters, but it's like, that's okay. We'll just let you stop at the end, and we'll start at 6 and go all the way to the end. Oh, no trace back. It's almost disappointing sometimes when Python doesn't trace back. When you think, you're so obsessed about everything, I would trace back in that situation. But hey, I guess if you're allowed. So there we go. Now you can eliminate or omit the first or last. If you eliminate the first, it assumes the beginning of the string. If you eliminate the second, it assumes the end of the string. And why you would do this, I don't know, but that's from beginning to end, so it's the whole string. So whole string, 8 through the end is thon, and up to but not including 2 is mo, right? So you get that. So just that's pretty simple. Once you've got the rest of slicing and the rest of string indexing, the notion of eliminating the first or the last of the colon expression, the first or second of the colon expression, I think is actually pretty intuitive. We've already been concatenating strings together. We overload the plus operator, and there is no space added. Remember when you're doing print, x comma y, you have to think when the answer is true. Is m in fruit? No, that's the answer to a question. Is nan in fruit? Doesn't have to be the same character, it can be more than one character, and the answer is true. And then you say something like if a in fruit, and so this is a logical value that returns a true or a false, and yes, we found it. So that becomes true in this particular case, so it runs a little indented bit. So in is an operator in this particular situation. In a for loop, in means something different, and we'll use in for other things as operators, as logical operators coming up in a bit. You can compare strings, and this has to do with the character set of your computer, the character set that Python is, but in general, it is lexicographically less than, lexicographically greater than. Uppercase and lowercase are a little weird. I think when we use used the max function earlier. The way my computer was set up, uppercase was less than lowercase, but equal to. So a string object has some built-in capabilities, and one of the built-in capabilities that the string object has is, here is a string object, and because, so hello Bob is still there, but so constants are objects or capabilities, things we can do and use. Some of the ones I use a lot, and we'll look at each one of these things.
Yeah, so here's our method find. I was gonna look it up on the docs, but I was assuming that he was gonna pull it up anyways. So it's not gonna be true. It's not gonna be true. Look at the values it outputs. We use the find function to search for a substring within another string. Find finds the first occurrence of the substring. If the substring is not found, find returns a -1. Remember that string position starts at 0. So we're returning the actual position of NA. So this would be the starting position is 0, 1, 2. So I'm thinking it's 2. It's not going to be true.
Says find me a string within a string, right? Find me a substring within a string. So find me the first NA and give me back the position. So that gives me back 2.
Yeah. I mean, I see what you would mean by like word.find. Does the characters NA, are they found inside of this string? It would make sense to return true, but in this case, we're returning the position because we're finding NA and where it's located. So it's going to be 2 here. Yeah. You think it's like the number 3? But why would it be 3? Because our index starts at 0. So if you count it, 0, 1, 2. So n starts at 2. So it would not give us 3. Remember the slicing part. If we wanted to get word indexed 0, so starting at 0 to 3, 1, 2, 3, it would give us everything before 3. Remember, NA. So it found NA, but it starts at index 1, 0, 1, 2. So it's right there in the video. Find position 2 of NA starts at 0, 1, 2. So it gives us the starting position. But remember, it gives us the first occurrence of NA. Sure, there's 3 of them, but the first occurrence is right here. So you're only looking at the first occurrence. That's what the find method is doing. Only the first. The rest of these don't count. They don't count. Just this one. So yeah, I mean, yeah, it would not be 3. It definitely would be 3. Even though NA does bleed into the third index, it found the first one, or NA technically starts on 0, 1, 2. What's the question here? What is used to indicate a new line in a string? Okay, for those of us who've programmed, this is confusing now, because now I don't know whether it's this one or this one. So it's the first one probably, but.
Hello and welcome to chapter 7. This is the chapter where it all really starts to pay off. We have been learning bits and pieces and doing little 2 lines, 3 lines, 4 lines of code to learn the basic building blocks of Python and learn some of the syntax and find lots of terms. But now we're actually going to start doing something. So if you look at what we've been doing so far, we have been 10 points. It's kind of where files to be. Files that we're going to talk about mostly are text files. And you can think of these as a sequence of lines in a file that are easily read by Python. You've been making text files all along. Your hello.py, that file's a text file too. You're using a text editor to create that file. You put your Python commands in a file, you run those files, and that's what it is. And so a file can be thought of as a bunch of lines, 1, 2, 3, 4, 5, 6, 7, blank line here. That's possible. But the reality is that these are actually just lines, and we have a special character called new line that we'll talk about in a second. So to read a file, you have to call the open function. And open returns what we call a file handle. Open doesn't actually read the file. Open makes it possible so that you can read the file. So the parameters to open are one parameter is required, which is the name of the file. Another parameter is optional whether or not to read it or write it. If we're reading the file, it doesn't harm it. You can read it over and over. If you write it, actually, if there's already data in that file, it truncates it and writes something. We're not going to really write files. We're mostly going to read them. And so open sort of, you pass it in a file, it gives you back this file handle, and then you have
I don't think we have this in JavaScript. I don't know if we have the ability to read files as easily as we do in Python.
Variable in which you store it. I often call it fhand to be mnemonic. You'll see my code. I use fhand all the time to indicate that it is a file handle. And so if we were to run this in interactive mode, we'll open mbox.txt, and that is a function built into Python, and then it gives us back a handle. It does not give the data. You can kind of see this when we print out the file handle using the print statement. It doesn't print the lines that are in the file. The lines that are in the file are sort of out there. There could be like 10 million lines for all we know, lines in the file. The handle's like a little opening outside of your program, and you can talk to the file by opening it. Then you can read stuff. If you're writing the file, you can write stuff, and then you close the file to shut the handle down. But handle is a thing that allows you to get to the file. It is not the file itself, and it's not the data in the file. It's just a wrapper that kind of allows you. So this, if you print it out, it's like that's the file we opened. We're reading it, and encoding has to do with the different kinds of character sets, which we talked about at the end of the last lecture. The Unicode character set, etc. UTF-8 is a great character set. It's probably the most typical character set that you'll run into, although you can have different character sets of files, but most of them are UTF-8. So of course, this is Python. If you make a mistake and there's a file that doesn't exist, we get a traceback and it blows up. We'll show you in a second how to deal with that. Now, the new line character is an important part.
There's our answer. We can stop the video. There's our answer. /n.
File reading. And in files, in strings, we can put the new line character in by this \n character. And the \n is the character that indicates that we're supposed to go to another line, go to a new line, go to a new line. And so we have, what is this? Well, that's a \n. And so if we print it this way, we see that the \n is in there. This is how we type it. We actually type \n to Python to indicate that we're supposed to put that there. But if we do a print statement, it actually interprets the \n. So the \n causes kind of this movement to the beginning. Now, print actually, at the end of this, adds another \n. So the \n that we put in by putting it into the string is that one. And then print always puts a \n at the end. There's actually a way to override that \n behavior by putting something on the print, which we'll talk about later. Now, it's important to note that the \n is one character, right? And so even though this x\ny prints this, and then print adds another new line to go down here, if you ask how many characters, what is the length of this? It's only 3. That's because that's a character, the \n is a character, and the y is a character. So it's a 3-character string.
So let's just go with \n. Like Dorilla said, this is the slash that we barely use. / is the one we use the most. Obviously, in URLs, everything is /. So /n is how, and that I'm pretty sure that's standard. Is that standard with most programming languages? Because I know in JavaScript it's the same.
So the \n is a character like all the rest of the characters, but it's only, we encode it by typing \n. It's called an escape, where the / is the escape, \n is a way to say new line, because we can't see it. It's a way for us to encode in a string this non-printable character, this invisible character. The white space, it's part of white space. So as we're reading through the file, we can think of it as a sequence of lines, and we can read these a line at a time. We can also read them a character at a time if we want. And so it's more common to say, read this line, read the next line, read the line after that, etc., etc., etc. But the way to best think about this, it doesn't really matter. You can think about it as lines, and we will in most of the programs that we write. But realize that the way when we see this, when we see it, it comes back to the beginning, it comes back to the beginning. There's a character in the file at each of these points to say go back to the beginning. It's like hitting the enter key on your computer, and that is a new line. So you have to think that in the file, in order for your text editor and Python and everybody to know where the lines end, you put new lines in the file, and that's another character. This looks like an empty line. This line here looks like an empty line, but really it has a single character, and the character is a new line. And it turns out that we're going to need to keep track of the fact that every line is ended by a new line. So up next, I'm going to talk a little bit about how to read files in Python.
There we go. Okay, so 30% of the way there. Let's keep going. Let's keep going. All right, so we're reading files now. What does the word continue do in the middle of a loop? We're going back to the loops now. I'm going to say B, or well, directly next. Okay, we have to kind of pay attention to what it is asking. Skips to the next block of code, skips to the next iteration of the loop, skips to the next line in the code, skips to the code directly after the loop. You say C, I say probably A maybe.
So we're going to find that there's a number of different ways that we can read through the file. But the most common way we're going to read through the file is to treat it as a sequence of lines. And we're going to use the determinant loop, the for loop, to do this. And so what happens here is we get back this handle that opens the file and gives us back the handle. That handle, X file, is the variable I named called. I just named it X file. That's not the data. But it is a sequence. It is that file handle represents to Python a sequence that we can potentially walk through and then get all the lines. And it's the simplest, most beautiful, elegant way to read all the lines in a file. We use the for loop, and we have an iteration variable. This is going to take, when we talk about the file, cheese is going to be the first line, then the second line, then the third line, then the fourth line. So it's like going through a string, but you're going through a file now, and you're getting it line by line. So that's each line. I just picked a variable named cheese, so you didn't get confused. Later I'll call this line. But Python doesn't know anything special by naming that variable line. Okay, and so this is, it's the for and the in, and so for, I read this as for each line in the file handle X file. So run this loop one time for every line and then print it out. So it's actually really quite simple. Okay, other languages like C or C++ or other languages, they have to write while loops with end of file conditions and all kinds of things that make this very difficult. But this is one of the prettiest things that Python has. It's a very pretty thing. Okay, so let's talk about what we might do. And we're going kind of back to iterations now. What if we wanted to count the number of lines in a file? This is a basic loop counting pattern. So we open the file, and then like in all these loops, we do something to sort of prime the loop to get it started, set variable count to 0. And I'm going to use the variable line that's going to go through each of the lines in the file, for line in fn, and it's going to run this loop once for each line in the file, and the variable line is going to change. But all I'm going to do is add count equals count plus 1. And so that's just like from counters, that's just how you detect. So every time we see a line, we're just going to add 1 to the counter. We're not printing the line, we're not looking at its data at this point. And then when the line is done, however many times it has to go, out it comes, and we print out line count equals count. And so if we open inbox.txt, this is going to do all this work and then print this line out and say line count 132,045. So this is a little 5-line program that shows you how to count the lines in a text file using Python. Again, simple and elegant and not too much syntax for you to have to learn. Now it's also possible to read the file as a series of characters, all in one go. Read the whole file. And now you got to be careful depending on the size of the file. This is going to lead to a string variable with a lot of data in it. Now if it's 100,000 characters, that's actually kind of a small thing. But if it was 10 million lines, that would probably not be good. You want to read it one line at a time and process each line and then do something. But inbox.txt is a small little file. So we open it and we get back a file object, file handle object, and we call the read method. And that says go through and read all the text and give it back in one big blob, one big string, and I'll put it in imp. And so that's where you have a line, a new line, a line, a new line, a line, a new line. It's not really lines, it's just a sequence of characters with new lines in there to punctuate them. And now you can split that, later we'll see how to split that into separate lines if you want. Now I picked a file that was short, and so this variable now has a string in it, and I can use the len function, pass a string into the len function, says, oh, 94,626 characters. That's kind of a small little file, and perfectly okay to read it all in one go. And so now I say just print the first 20 characters, that's beginning up to 20, and so it shows that the first 20 characters of that little file is a from line, because this is a mailbox file. Now let's say we're going to do a searching, and we did this loop where you're looking for something. And so we're going to search for lines that have a prefix of from, okay? That's what we're doing. We're going to print those lines out. So there's lots of lines in this file, and from, right? On and on and on. And we want to show these lines, the ones that match, right? That's what we want to do. And so we are going to write an open statement, and then we're going to loop through, and we're going to ask the question. If the line starts with from, print it. So sometimes it's going to skip, and then it's going to run it, okay? So that's the basic idea, and then it'll finish when it's all said and done. And so this is like a criteria. This is like a search. We're looking for lines that match the string, that have the string from as their prefix. Now, when we look at the output of this, where you're looking for something, and so we're going to search for lines that have a prefix of from, okay? That's what we're doing. We're going to print those lines out. So there's lots of lines in this file, line from, right? On and on and on. And we want to show these lines, the ones that match, right? That's what we want to do. And so we are going to write an open statement, and then we're going to loop through, and we're going to ask the question. If the line starts with from, print it. So sometimes it's going to skip, and then it's going to run it, okay? That's the basic idea, and then it'll finish when it's all said and done. And so this is like a criteria. This is like a search. We're looking for lines that match the string, that have the string from as their prefix. Now, when we look at the output of this, it's...
For context, they covered looping before this. They covered general looping before this, and now we're just going over reading files with looping.
Kind of weird. We see kind of these little blank lines that show up blank. What's going on here? What's going on? So let's take a quick look. The problem is new lines. Well, I mentioned that the file has new lines in them. And so when you do the for loop, it doesn't throw the new lines away. As you might expect, it would be kind of nice if it did, but it doesn't. It actually shows you when you read, it reads that first line up to and including the new line and gives you that back as the variable. So that is the first new line. So that means it's going to go down. And then the print statement actually adds another new line. So that's the second line of the file has a new line at the end of it, and the print statement adds another new line. So if we take a look at the code, there is a new line. Oops, come back. If we take a look at the code, this variable line has a new line in it. Oops, I'm in the wrong. Yeah, this one I want to do. If we look at the code, there's a new line in here, and then the print adds another new line. So the print adds a separate new line. And that's how we get two new lines. lines. The print statement's new line and the new line from the file. Here's how we fix it. And you're going to write this code a lot because when you're reading text files, you have a new line, but you don't want the new line. But thankfully, as we saw in the previous chapter, there is a nice little function in Python for strings that allows you to throw away white space. And to review is anything that doesn't print. And this new line is not a non-printing character. So rstrip gets rid of it. So it's a way to get rid of white space. And rstrip does it from the right end. So it's the right end of the string. And so if we just are going to loop through all the lines in the file, we say line equals line rstrip, and then this variable no longer has a new line at the end of it. We have our little if statement. And if we print it, then this line, the data has no thing, and then the data has no new line in it. So the print only goes down one. And so now we have single spaced output. And so you're going to be doing that a lot. It's really common to read through a file and then just strip the new line or any trailing space off the end of that. Now, there's a couple of ways to do a loop like this. And let's just think of this as we're looking for a file with lots of different lines in it. And we want to ignore all the lines except some say good lines. And we want to do something with those good lines, or the lines we're looking for. Needle in a haystack. This is like searching for a needle in a haystack. So if you look at this code at high level, we're going to loop through everything. And then we're sort of picking which lines are, and these are the good lines down here. Now, often we have a bunch more code that we want to do, and we're not just printing them, but we're going to do a lot of code. So sometimes you actually structure the loop a little bit differently. And so the way to do it, and this is going to do the exact same thing, it's just a little different way of thinking about this loop. So the top part is the same, we're stripping it. And what we're doing here is everything's the same here, except we add this is not. If the line does not start with from, that's the translation of that. If the line does not start with from, continue. So basically we have a skipping pattern. So the lines we're not interested in, we skip. So we come down, we skip a lot of lines. And then we find a line that's good, and then we fall through. So this is the good code. And then we have all the other good code that we want to do to that line. We have that showing up down here. And so there's just two patterns, two ways to do the exact same thing. So another way to select the lines that we're interested in is to use the...
In order for our answer, skips through the code directly after the loop, right? Skips. It could be A or B. I feel like these are like the two same things. I feel like he's going to continue though.
In operator. So we talked before about the in operator and how that works. So we're basically going to use the continue skipping method. So we're going to read all the lines, these first few lines. If uct.ac.za is not in the line, skip it. And so this is going to print out all the lines that have this in them. And so you see this is the output.
You said it's C? Oh, that makes sense. That's true. That's true. That's true. You're right. Okay. This is where I was getting confused. All right. The wording is like obviously the hard part to kind of decipher. Okay. That makes sense.
Sometimes you'll have programs that want to read different files. Often I give assignments where I say, show me how this program runs on the short file, and then show me again how it runs on the long file, just like this. And so the way we do that to input the file name, instead of making the file name be a constant to the open call, we make the file name be a input. So we just run an input statement, which gives us a prompt, and then we type mbox.txt, and then that shows up in this variable f name. It's of course a string all the time. And we pass that into open, and then we open it, and then we do the count operation. So if we enter mbox.txt, it counts 1797 subject lines in mbox, and if we give it mbox short, it says there are 27 subject lines in mbox. And again, this is another one of those ifs, and it's just counting, but only counting lines that match a particular. Okay, so now the user can also type bad file names, and we need to be able to deal with that as well. And so we're taking a small change to the code. The dangerous code is this line right here. This line right here is going to trace back if that file doesn't exist. So what do? We're going to just expand that. The rest of this program is exactly the same. Nothing's different. Is we've got this line. We took out insurance on it, and we know that it might blow up, and so we have it in a try and accept block. So here's how the code runs. The input runs. We type in a good file name. It comes in here. This works, and so it skips the accept, and so it runs the code and prints out the count. So that's the good pattern. The bad pattern is here. We're typing a bad file name. It comes in the try accept. This file name is nana boo boo, and it's going to blow up. So this line blows up.
Great file name. That's a great file name. Nana boo boo.
Done at the accept code. Out file cannot be opened. So it prints this out. Now this quit is really important because if we don't put this quit in here, it's going to continue down here, and it's going to blow up here because file handle is not defined properly at this point. And so what we have is this is a special function where it comes in and never returns. So this is a way to terminate the entire Python program silently with no traceback. Right? So we put in our own error message, so we look like we're professional. Say, could not open this file, and then we stop. If you don't, it's going to come down here and it's going to trace back right there. It's going to blow up. So quit is useful when you want to stop executing because you detected some kind of an error. So that's a quick zoom through opening and reading through files and doing some.
Okay, so we said C. Yeah, the whole continuing and breaking thing is interesting. Breaking is what would put us to the next block or the next line of code that runs after our loop, but going to the next iteration of the loop, like going back. So his diagram showed like an arrow kind of like where the continue is. If we see a continue, then we go back to the top and do the iteration again of the loop. So C makes sense here. Okay, so now we're going through lists. So what is the value of x after running this code? Fruit equals banana, x equals fruit 1.
Hello and welcome to Chapter 8. We're going to talk about lists in this chapter.
Algorithms are the concept in computer science of using a programming language to express the steps that you want the computer to go through to solve the problem. Read some data, convert it to a floating point number, check to see if it's greater than 40, do one thing if it's greater than 40, do another thing if it's not, then print out the result. Or file, read everything. If the first line starts with something, do something. If not, skip it. Those are steps. Those are a series of steps, and hopefully by now you're getting to the point where you have a good understanding of steps. But there's a whole other side of computer programming, and we call it data structures. And data structures is not the steps, but instead clever ways that you lay out the data and clever ways that you make sure that the data does what you want it to do. And so that's what we're going to start talking about now. Lists are the first and most simplest data structure. Strings are kind of like data structures, but lists are probably our first real data structure that we're going to think about and design and make use of effectively. But before we talk about what is a collection, we should talk about what is not a collection. So we're familiar with what a variable is. We know that a variable is a little piece of memory that's got a label on it, and then an assignment statement sticks a 2 into x, and then 2 is in this little cupboard, and then it goes to the next line, and then 4 goes into x, and so the 2 goes away and the 4 is there. A key thing is you can't have more than one variable at any given moment, right? And more than one value in a variable. So when we move to collections are more like suitcases. We can put lots of things in them. We have ways of organizing them, and as we go through lists and dictionaries and tuples, we'll see how there are different ways to organize them. And as a matter of fact, we've been talking about lists for a while.
Or well, a list is a kind of collection. Okay, I see.
And we use one of these square bracket syntaxes. In earlier programs, we've been working with lists. And so this is technically a 3-item list with 3 strings, got commas here. Joseph is one string, Glenn and Sally are another string. And here's another one that is another thing. And the list is basically, it's a list.
Yeah, okay. In any list or anything like that, everything is 0 indexed. So that's Yeah, it's 0 index. So everything starts with 0.
Constant, and it's being assigned into a variable. So this friends variable has 3 things in it. So that's different than what we've been talking about before. So these brackets and bracket structures with square brackets are those lists. And so the print is just a print with parentheses to get the print to work. But 1, 24, 76 is a 3-item integer list. Red, yellow, and blue is a 3-item string list. But it doesn't all have to be integers or strings. Python can handle different things and different kinds of data in different positions in the list. So red, 24, 98.6, a 3-item list with a string, an integer, and a floating point number. And while we're not going to use this too much for now, this outer list is a 3-item list, and the second item is another list. So this is kind of alluding toward what we'll do when we start talking about data structures. And that is, we have a structure and then we have another structure inside of it. And sometimes this can get quite complex. And we're doing this for a reason. This here has no reason, just to show you that it's possible that lists can be made up of lots of things, including other lists. And of course, there is also the notion of the empty list. And like I said, I have had to be able to tell you about lists all along. We use them in for loops. We can put lots of things here. We can put file handle here. We can go through the file. We can put a string there. We can go through the characters in the string and in a list. And the iteration variable then goes through the successive elements of the list. And that's why this prints off y4, 3, 2, 1. And then the loop is done and it prints out blast off. So we've been using them and we've been actually iterating through lists with for statements all along. So the for statement has been something we use with lists. And when you just need to go iterate through the list and go through every item in order, the for is a great way to do that. So friend is our iteration variable. Friends is our list variable. And so that says friend is going to successfully take on the value Joseph, Glenn, and Sally and print out Happy New Year, Joseph, Glenn, and Sally. It runs 3 times, once for each of the values, and the iteration variable advances. Now, I do want to make it really clear that the choice of friends and friend singular and plural is arbitrary and capricious. It happens to be convenient and intuitive that the iteration variable is 1 and the list variable is more than 1. But Python has no idea about singular and plural. As a matter of fact, Python would care. It would be totally equivalent for Python to do the same thing, to have the list variable be z and the iteration variable be x. X will take on the successive values of these 3 things. Now, am I being nice to you by calling this list friends and this iteration variable friend? I am, but I also don't want it to confuse you if you're just a beginning developer. So, just like strings, we can sort of look within lists. Part of the thing is when you put more than one thing in a data structure.
But the thing with this is like, I always forget which one you can't change the values of. I don't remember if that's a list or a tuple or
you need to get
dictionary.
And so lists have positions, they maintain order. And so the first thing in the list is the sub-0 position, sub-1, sub-2. Just like strings, they're 0-based, just like European elevators, they're 0-based. So if we take a look and we say, oh, friend sub-1, that's how I read that. The little square brackets, when you take a variable here and you say friend sub-1. Remember, singular and plural don't matter. Friend sub-1 means Glenn, because this is the 0 and that's the 1, and then Sally's the sub-2. And so that's what prints Glenn out in this particular thing.
So that's your answer. Again, like you're probably around, we're only halfway there, but that's answered the question.
Lists are mutable. Mutable is another word for changeable. They can be changed, meaning that a list has 3 things. You can change this thing right in the middle if you
So lists are mutable, meaning we can actually change the value inside of a list.
To take a look at what's not mutable, strings are not mutable. So if I take a look at assigning banana into fruit, well, fruit sub 0 is a capital letter B. Could we imagine for the moment that we could change fruit sub 0 to lowercase b? Well, the syntax would be how you would do it if you could do it, but it turns out that strings are not mutable, meaning they're not changeable once you create them. And that's why when we do things like lowercase or uppercase, we take a look at the fruit and we say, give me a lowercase copy of that, and then we take the return value from this and we store that in x, and that's how x becomes a lowercase banana. But fruit is still the original one, so fruit has not changed. Compare and contrast that. A list, though, here we have a 5-item list, 2, 14, 26, 41, and we're going to do the sub 2 position, and the sub 2 is 0, 1, 2, so that's that one right there, and we're going to assign a 28 into it. So that 28 is going in here, going to wipe that out and put 28 in. So we can do item assignment in lists by putting a bracket syntax on the left-hand side, say don't just put it in the variable, put it in this position within the variable. So that's what that's doing, and when you print that out to 28, everything else is unchanged. I mean, the whole list is there. There could be 1,000 items in the list, and then you're changing the second one.
So then that means tuples are the immutable version of a list. Lotto? Like the lottery? That's probably what he's referring to. Like lottery numbers.
We have a function called len. We've been using this len function all along to take a look at how long strings are. It counts the number of characters in the string, so that's a 9-character string. If we have items in a list, len tells us how many items there are. It's not like how many characters there are, it's the number of things. And each thing doesn't have to be a number. It could be a number, a string, or even another list. And len is the way to say, hey, how many things are in there? There's a function that returns a list of numbers, and we use it, as we'll see in a second, to construct specialized loops to go through lists. So let's take a look at this range function just for a minute. So range takes as its parameter the number of numbers that you want returned.
The range function returns a list of numbers that range from 0 to 1 less than the param.
So I'd like an item list with the numbers 0 up to but not including 4. And so it just turns out that is really useful for constructing for loops that are counted for loops that go to 0 to the 1 to the 2 as compared to the definite loops that go to each one. And so it's a common thing to say, okay, we know how many things are in this list. There are 3 friends. And if I combine range and len, so I take len friends, which is 3, and then I take range sub 3, I get 0, 1, and 2. And so the interesting thing is this 0 corresponds to the first one, 1 corresponds to the second one, and 2 corresponds to the third one. Okay? And so we'll use this to construct loops, especially when we need to go through an array and remember what position we're at. And so here's just an example of two different loops. This is a for loop that's just going to go through whatever's in this list. So friend is just going to take on the successive values, and so it's going to print out these three things just as you would expect. And if you don't need to, while you're going through the loop, know the position, your relative position from the top in the loop, that's okay. But sometimes you want a little more sophisticated loop, and instead you want to be able to loop through where you're the position. And so what we do instead is, instead of looping through the list itself, we do range len friends, which gives us 0, 1, 2. And then I takes on the successive value 0, 1, and then 2. So this loop is going to run 4 times, and I is 0 the first time. And we might even just look up the value inside that sub-0 value, so we get Joseph the first time. So prints out Happy New Year Joseph, goes, and I becomes 1 now, and so it gives us Glenn, and that prints out, and away you go. If you look at these two loops, they really do the exact same thing. The only difference is this we allowed the for to find its way with the iteration variable through, and here we created our own I variable that went through the positions, and they're dense, there's no gaps in here, so it's 0 through 2 that it goes through. So these two are equivalent. There will be times when you want to use one and the other. I tend to prefer the first one because it's prettier as long as it works for me.
I understand the second one a little bit more coming from JavaScript, but that's just me. Okay, so we all said A. This is pretty much the answer to it, right? Very good. All right, which method is used to add an item at the end of a list? Okay, chat, what do we think? Insert, push, append, new. What do we think? What method do you think adds an item to the end of a list? I always got confused here with JavaScript. Everyone's saying append. Okay, we won't check it, but let's watch the video.
Okay, so we've taken a look at loops, and now we're going to just take a bit of a look at some of the operations that you can do with loops. Python has this, as we'll soon learn, object-oriented approach to its operators, and the plus can add strings and it can add numbers. It can add floating point numbers, integer numbers, strings, etc. And so the plus similarly works this way with lists. The plus looks to its left and looks to its right and says, what am I adding? And in the case that I'm adding the list 1, 2, 3 and the list 4, 5, 6, it concatenates them together. In this way, it sort of functions like a string, and so we get 1, 2, 3, 4, 5, 6. It just concatenate this list to another list. And it doesn't change A or B, just like in any kind of assignment statement. Calculations on the right side don't change the variables and then produce a new variable and then assign that into C. You can also use list slicing. It's easy to remember. If you remember how strings work, list works exactly the same way. So of course it's a little tricky. The first number is the starting position. They start at 0. So 1 is right there. So it's the 0 position, the 1 position. Start it right, but go up to, but not including 3. There's 1, 2, 3. So this goes up to, but not including 3. And that's why we get 4112 out of that. So up to, but not including. I'll just say that over and over again. If we do, you can leave the first part out. You can leave the first part out here, and you can say, oh, up to, but not including 4. So that starts at the beginning, goes up to, but not including 4. And so that's how we get that piece right there. We can say start at the position 3, 0, 1, 2, 3, start at position 3, and go to the end. The fact that the number 3 is in here is sort of irrelevant. 3 to the end is those 3 numbers. And then you can do the whole list. To remind myself of them, append will look at, count looks for certain values in the list, extend adds things to the end of the list, index looks things up in the list, insert allows the list to sort of be expanded in the middle, pop pulls things off the top, removes an item in the middle, reverse order of them, extend adds things to the end of the list. Some examples I used when I was doing strings, they're pretty much the same. There's a number of different methods, and you can look up all the documentation in list. I often just use the dir command to remind myself of them. Append will look at, count looks for certain values in the list, extend adds things to the end of the list, index looks things up in the list, insert allows the list to sort of be expanded in the middle, pop pulls things off the top, removes an item in the middle, reverse flips the order of them, and sort puts them sorted order based on the values. So let's look at a couple of these. If we build a list from scratch, we have a way to ask for an empty list. There are a couple of different ways to ask for an empty list. We could use just 2 square brackets next to each other, but this is a form we call the constructor form where we say, hey Python, make a list. In this case, the word list is like a reserved word to Python, the reserved class, but say list parentheses says make me an empty list, and then assign that list into stuff. So stuff is now it's a list object, it's of type list, but it has nothing in it. And then we can call the append method stuff.append and stick book in. And then we say, oh, and that knows how long, the stuff knows how long it is, where the end is, and how to add something to it, and then add a 99 to it, and we print it out. We got book and 99, reminding ourselves that lists, while they're often the same types of variables.
So this answers the question, right? It's append. Everyone got it right. Good job, chat. Append is what puts items at the end of the list. So we created a new list using the constructor method here of list. So stuff is our new list. And we then appended book. Doesn't matter. It's going to be it technically is the beginning and end of the list. And then we appended a 99. So that's going to go to the end. And then at the bottom, we appended cookie or string of cookie. And that goes behind 99 at the end of the list. So
types of values in the various positions in the list. It doesn't always have to be that way. Then we say, oh, we'll stuff.append cookie. You can keep on going. And then we end up with 3 things. We have an operator. Works pretty much like the in operator in a string. Is 9 in my list? And that's pretty simple. And the answer, of course, is yes. 9 is in my list. Is 15 in my list? Looking through, no, it's not. 15 is not in my list. And then there's the not in operator. Think of that as one operator. Is 20 not in the list? And the answer, since it's not there, is true. And so that's a way to just what's kind of like starts with or in for strings, same kind of stuff. Lists are in order and they're sortable. And so this is something that we take good advantage of. A lot of what computers want to do is sort stuff. Look all these things up, append them, and then get them sorted. And so there is this method inside of list. That's just the sort method. So here we put 3 values in 0, 1, 2 position, 0, 1, and 2, Joseph, Glenn, and Sally. And then we tell the list to sort itself, and then we print it out. Now, this is actually sorted the list in place, which is different than upper and lower, because if you remember, strings are not mutable, but lists are mutable. And so you say, hey, just sort yourself. Okay, and so just sort yourself, and then it sorts it, and then it's in alphabetical order, Glenn, Joseph, and Sally. I happen to be clever. I only put strings in there, and I put my uppercase and lowercase in a very consistent pattern, but the list is changed. And if I look at list sub 1, that is the second item, which is Joseph, that prints out right down there. There's a whole bunch of built-in functions to help manipulate list. The other things I was showing was sort is a method that's part of list, but there are other functions that take list as their...
I feel like we could go through this later at a different time. Like if you want to look at the different built-in functions,
all those looped
and things that you can actually just go through the documentation and learn that.
It's going to repeatedly ask for numbers until we type the word done, and then it's going to compute the average and tell us what they are. And so using sort of the stuff from the loop chapter, we start with...
These are also good questions to look up if you're trying to do something. Like if you're trying to look up the average of something, like Stack Overflow is going to be like your best friend here. Very good. It was append. All right, let's keep moving. Strings and lists. What does n equal in this code? So words equals his email is qlar@freecodecamp.org. So this is a string. Pieces equals words.split. And then parts equals pieces at the third index dot splits at the hyphen. N equals parts index 1. I think it's D because here we're splitting all the words. So all of these are now individual and it's not one string anymore. Parts equals pieces at index 3. So 0, 1, 2, 3. So this is its whole string, but then we split it at the hyphen. And so these two are now completely separate words. And then we say parts 1, which is 0, 1, which is going to be this whole thing here.
So now we're going to wrap up and talk a little bit about how strings and lists are related. They're sort of related in that they both have zero-based things and we use the square bracket operator to do various things. But there's a lot of situations where we're looking at our data and we're combining the use of lists and strings. So let me show you the first thing, probably the coolest thing. We're going to use it a lot the rest of the class, and that is the split function. So let's take a string. We've got ABC here. It's with 3 words. What we're interested in the fact is that there's spaces in this word. And what split does, it says, I'm going to look through this thing, I'm going to find this, and I'm going to break this into pieces, and I'm going to return you a list of the separate individual pieces. So look for blanks and break it in pieces and give me back the pieces. So I'll print these out, and now you see that it's a list with 3 items, with 3 words. The spaces are gone, but it's given it to us. So it's like, split this into words, please, and give me the individual words, and give me a list of individual words rather than a big long string with spaces in the middle of it. And that is a quick way to go from a line, and it's really common. A lot of things are going like, go get the second thing or the third thing or whatever. So the split's really nice because then you can just grab stuff. And so you say, oh, how many things did I get? I got 3. The len function tells us that. And I can print the first word I got, which is with a sub-0, and that'll be like with, will be the first word because that's the sub-0 position. So I read something, I can say there's 3 things, and I can look at stuff the first word basically without really knowing much. Now, if you remember earlier, and we'll see this, we used find and slicing to do a similar kind of thing, but people tend to prefer the split. And you can, oops, go back. You can also then loop through them. So you can split these things into stuff as a word and then go through with W, and then it's going to...
Yeah, so see, split, we just separate each character based off of the spaces, right? So I think with split, like we noticed before, you can actually add a parameter of where to split. So if, with the hyphen here, these now become 2 individual words.
It's going to go through, W is going to take the successive with 3 words. And so you can make a loop by reading some data, splitting it, then writing a for loop, and then it's effectively going through the words in that line of data. And so that's a really powerful concept that we'll use in a lot of the...
So this is a great explanation. Split breaks a string into parts and produces a list of strings. We think of these as words. We can access a particular word or loop through all the words.
Programs that we're going to write. Just a couple of bits about this and how it works. Split with no parameters here. It looks for spaces, but it also treats a bunch of spaces as a single space. And so it's pretty smart about that. And so even though this has a lot of spaces between lot and of, you only see lot of, all the spaces are gone. It does something special about spaces. It's really white space, so tabs or new lines or other characters would also qualify in split, basically. Now, you don't always have to split based on spaces, and a lot of data that you're going to run into, you're going to want to split on something else. And so here's some data that looks like we're using colons to separate the first, second, and third piece. Now, if you just call splits looking for spaces, and so split gives you back a list of the things broken apart with spaces, but there's not a single space in that line, and so we get a list. See, it's a list, but there's only one item, and the semicolons are sitting there. Split doesn't go like, whoa, this looks like it should be semicolons. Split's job is to use spaces and split the string based on spaces, okay? But given that this is something we like to do, you can tell split what character you'd actually like to split on. Now, it's not quite as clever when splitting on something other than spaces. It doesn't understand that if there's a bunch of semicolons in a row, it still thinks of those as splitting points to split. But in this particular case, when there's no spaces, it's going to split that. So it says split this based on the semicolon, instead of being based on the space. So if you take a look at what comes out of this, we split on semicolon, now we have a 3-item list, and we get first, second, and third.
Yeah, so this is exactly what I was talking about, right? So if we add a parameter here, in this case, we're adding a parameter of a hyphen. So we're splitting based off of that hyphen, and we want everything except for that, but we're counting this as a separator here. So we're looking at Q and lar. These two get separated because we've added that as. So when you do not specify a delimiter, multiple spaces are treated like one delimiter. You can specify what delimiter character to use in the splitting.
A lot of your data comes out of some logging system or some router status updates. Who knows what you're looking at, but the delimiter is often something other than space, and you can do that with split. So this is a useful thing when parsing things like our email address, right? We wanted to get things like the email address, this second piece, off of the line. And so we can use split to take advantage of this. And so here's a little loop that's just going to print out not the email addresses, but instead the day of the week. We're going to print the day of the week out for all these things. How do we do that? We can observe really quickly that if we split based on spaces, it's the 0, 1, 2. It's the 2 position. So we can quickly write a bit of code that opens the file, then loops through the lines. We do this all the time now. Strip takes off the end of the new lines. We can check to see if it starts with from space, right? From space is our key, so we're ignoring all of the lines that don't start with from space. But then we find a line that starts with from space, and we split it, and then we just print out the second word. And so we get the second word of the lines that start with from, and that's how this thing works. Sometimes we want to dig into it deeper, and we will take something, split it, and then split another piece of it again with a different delimiter. So let's just say that the thing that we want to achieve is getting the part after the @ sign for email addresses. And we did this with, again, find and pose and stuff like that, but you can use split to do this as well. So the first thing we're going to do is we're going to take this line, we're going to split it based on spaces, right? Chop, 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 and the fact that there's an extra space there doesn't matter. Split happily just like zooms through that. And then words sub 1, 0, 1, 2. Word sub 1 is this email address, so we'll put that in a variable called email. And so email will be a string that's just this. So in 2 lines, we've pulled out the second address into a variable. Then what we're going to do is we're going to re-split that. We're going to take this string we've got and split it based on @ sign, because we know it's an email address. So we get a new set of pieces. The first part is the person's name, and the second part is the host name that their email is hosted on. And then what we can do then is we just happen to know that this is the 0 item and this is the 1 item, so we can get at that. So the interesting thing of going here, if you think back to how we did this before with find and pose and all that stuff, it's really a lot cleaner. And we don't, for me, I can look at this after you understand it, and it's easy for me to understand that it's correct. Whereas that pose stuff, you got to add one and start the second find after. Just remember that. And this is a lot cleaner way. And this is a more typical way of pulling this kind of information out.
Okay, so we can all agree that on this, since we understand what like splitting is, like we can split all of these words individually. So now we have his email is, and then QLR. So there's 4 items, 0, 1, 2, 3 in this list. And now we go into the pieces list, assigning it to the parts variable. We go to the third word. So 0, 1, 2, 3, which is this whole thing. And then we split it again, but our delimiter now is this hyphen. So this now becomes its own list with this being split. So we have Q, and then we have lar at freecodecamp.org. Okay. And so then we go into, we assign another variable n equals parts. So we're in this list, index 1, which is 0, 1. So now it's lar at Freecodecamp. Bam, baby. Okay, so this is Python Dictionaries. So let's see. What does dict equal after running this code? So dict equals fry 20, Thursday 6, sat 1. Dict Thursday equals 13, sat 2, and then sun 9. So we have Friday, Thursday's changed to 13, so this is out. Saturday is changed to 2, Sunday is 9. I think it's going to be D. I think it is going to be D because the rest of these don't. Yeah.
Hello and welcome to Chapter 9. Now we're going to talk about Python dictionaries. Python dictionaries are probably the thing that most programmers love the most about Python because they're very powerful. They're like a little in-memory database. It's the second of our kinds of collections and probably the best collection. To review what a collection is, it is a situation where we are going to have a variable, like a list or a dictionary, but we can put multiple pieces of information in rather than a single piece of information. And of course, prior to collections, we would put something into X and then we would put something else into X and it would be overwritten. And now with lists, we can append things on at the end. And so if we compare lists and dictionaries, the list is sort of the organized version of the collections. Everything stays in order. You add something, it always adds to the end. You take something, it sort of compacts itself. It's 0 through n-1, where n is the number of items. And so it's very organized, kind of like a Pringles, where the potato chips are nicely stacked. Dictionaries are messier. You can put things into dictionaries. There's no real sense of order in dictionaries. Everything has a key. So you sort of throw things in and they kind of mix around in there somehow. And you pull things out based on the key. It's like you sort of stick a label on it, or you say, okay, I'm going to take this thing and I'm going to put Chuck on it. And I'm going to take these sunglasses with the Chuck label and I'm going to throw it into the dictionary. And I'm like, hey, give me back Chuck. I'm like, oh, here's your sunglasses, because you mark everything. This is the value. I took a pair of sunglasses and I threw it in. So it's kind of like a purse, or it's sort of like a mess. And so the idea is you have these labels that you put on everything that you're going to throw in. Like I'm going to put, won't stick to my keys. Now what else do I got here? I'm going to stick a label on my pen, Chuck label, and I'm going to store a pen in my dictionary with the Chuck label. And so it's like having a purse or a bag or a backpack where you have things labeled and you can throw things in and label them, and you can shout into your bag and say, give me the calculator or give me the candy or whatever it is that you have labeled them. You have to come up with the labels, and then you can use the labels to get things back out. And like I said, they're probably the most powerful thing. And they're basically this concept that's generally referred to as associative arrays, which means they're like lists, but they have these keys. And so the associative means the association between a key and a value. Whereas in a list, there's a position, and a position is less powerful and less flexible. Most modern programming languages have this notion of associative arrays. If they don't, they're sort of unpopular because once you get using them, they're like, they're so powerful. If you ever find yourself in a language that doesn't have them, you'll freak out. They have different names like property maps or hash maps or property bags, depending on the language you're using, but they all are the same thing. They're key value pairs. So the idea of a dictionary is that the idea of any collection is putting more than one thing in. And then the difference is that you have ways of indexing it. So this basically line says, let's make ourselves a dictionary, just just like we constructed an empty list. And I want to store 12 into this dictionary, and I want to label it money. And so on the left-hand side, when we use this money, that's the label that we're going to give it. And so 12 is being placed in the dictionary. That's like taking the 12, throwing it in the dictionary with a label of money. 3 is going in with a label of candy, and 75 is going in with tissues. And we say, what's in there? And there's no order to it. And sometimes the order can even change inside of a dictionary.
What he just said is key here. The orders can change. So it doesn't necessarily mean that Sunday is going to get appended to the end. So this technically could be valid. It could be here.
Now let's just not worry about the ordering of them. If we say what's in there, you say there's 3 things in there. There is 12, 75, and 3, and stored under the keys money, tissues, and candy, respectively. We can ask, as an index operator, what is purse of candy? That's like saying, hey, give me back candy, and out comes number 3, which is that. We can update stuff. So we can say, like, go grab the candy version, add 2 to it.
It can't be V.
Now we see that candy has been set up to be 5. And so if you look at the difference between lists and dictionaries, they both can have new items added to them. We haven't talked a lot about deleting, but items can be deleted from them. The difference is the indexing mechanism, how we look things up, how we store things, and how we look things up. So we make an empty list, we make an empty dictionary. We add 21 to the end, and we add 183 to the end, and we ask it and says, oh, position 0 is 21, position 1 is 182. We don't see the positions when we print it out because it's sort of implicit. Here we're going to mark 21 with age and stick it in, and mark 182 with course and stick it in, and then we're going to print it out, and there we got course and age mapped. And we can add 23 and stick back in age, and that overwrites. So the 21 becomes the 23. We can do the same thing in list, except we say list of 0, because in list the indexing is position, and so this 21 becomes, and again, you just look at them and you can think of each of these as pretty much doing roughly the same thing, except the indexing mechanism. The values are the same, but the keys are different. So in list, the keys are always the position, and you don't get to assign those other than the fact that the order in which you put them in implicitly assigns a position. And in dictionaries, the key is a string. You can actually use other things. I use strings a lot in this lecture, but that just kind of keeps things simple until you get good at it. You can actually use numbers as the dictionary index, the dictionary keys if you want. But the values are things you put in and manage in those dictionaries. So we can, just like lists, we have dictionary literals. And what's nice about dictionary literals is that they use the exact same syntax as the printout. And so it starts with a curly brace, ends with a curly brace, and then has a series of key, colon, value, key, colon, value. And this is sort of the associative array bit. We are associating 1 with the key Chuck. We are associating 42 with key Fred. We're associating Jan and 100. Then we print it out, it kind of looks exactly the same. So the print statements in Python are nice in that you ask what's in a thing, you show the stuff, and it shows you in the syntax. If you type that into Python, that would be how you do a constant. And if you just say empty array, you can also do dict. This is constructor where you say make a new empty dictionary. This is an empty dictionary constant. These two things are pretty much the exact same thing. This is a shortcut to doing this. The curly braces is a shortcut to do the construction. So up next, we're going to talk about sort of
Okay, so then that means our answer here is going to be valid because we can't have the same keys as you guys have mentioned. Same key names. And so Friday was overwritten, or no, sorry. Friday was not overwritten. Thursday, Saturday, and Sunday. Thursday and Saturday. Let me slow down a little bit. Thursday and Saturday were overwritten because those keys already existed inside of our dictionary. And so Saturday instead of 1 becomes 2, and Thursday instead of 6 becomes 13. And Sunday is a new key. So I guess in terms of what he was saying, it doesn't really matter where it ends up in the order, but we do see that it does end up in here with the value of 9. And so D has to be our answer. Very nice.
So now we're going to talk to you about one of the common applications of dictionaries, and that is making histograms. It's counting the frequency of things. And so if you think of a histogram as a little graph, and there is how many A's, how many B's, and how many C's, and there's a histogram that says, oh, there's this many of that and this many of that. And these are like buckets. These are frequencies, and this is how many times it happens. So a histogram. But we're going to do this thing where we're going to count people's names, and we're going to kind of count how many that we see. The interesting thing that we're going to solve, just like many of the things in the computer, is we can't just sort of look at the data. We got to look at the data iteratively, one piece of data at a time. So I'm going to give you a little problem. Okay, I'm going to show you a series of names, one at a time, and I want you to count for each name, make a little bucket, and then keep counting how many things for each of the different names. Okay, you'll notice that you have to start with 1 and then you move across. So just watch this and tell me what's the most common name of the set of names I'm about to show you, and how many do we see?
I like this. Marquard, Zen, C-Seb, Zen, twice on Zen, C-Swen, 2 on Marquard, 3 on Zen, 2 on Swen, 4 on Zen? Okay, I lost track, bro. 4 Marquard, 4 Zen.
So what was the most common name and how many times did you see it? That's the question. Now, here comes the reveal. So for humans, it's so much easier for you to just look at this and you think, how did my brain look at that? And you're like, oh, it's pretty common. Oh, maybe Chen is common. Oh, Chen, no. Maybe Zhen is common. 1, 2, 3, 4. Yeah, anybody else have Marquard's got 3, C7. And so you'll notice how our minds, without computers, we just sort of like branch and bound. We have hypotheses, and then we decide, no, it's Zhen. That's it, and there's 4 of them. How did your brain think about this as we were going through them one at a time? My guess is if you really had to do this a lot, you would make a little picture like this. And then what you would do is if you saw a new name, XYZ, you'd add it to the list and give it a tick mark of 1. And then if you saw like C7 again, you'd give that a tick mark. And if you saw XYZ again, you'd make a tick mark. And then you'd keep adding to these tick marks, right? And that's how you would do it. And you wouldn't, like many of the things we do in a loop, you wouldn't really know what the most common was until the end. And then you'd sort of take a look at these numbers and you say, okay, that's the most common number. And then you'd be done. But you have to watch them one at a time. You can't just bounce around. And so that's how we're going to use dictionaries to achieve that. Again, instinctively as humans, we just look at the stuff. But if you had a million things, you probably want to write a Python program and use dictionaries. And so this is the idea. And there's 2 basic things that happen. One is the first time you see a name. You can say, is this name there already? If it's there already, you really just want to add 1 to it, right? That's the adding of a tick. Or you want to see for the first time, blah, 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 and give it a 1. And so you can use the name as the key, and then 1 is the value. And then first time Chen, you stick 1 in there. And so at this point, inside the dictionary, sort of dynamically adding as soon as it sees a new name, it adds another slot in here. But then if you see the same name again, like Chen again, then you end up with a 1, add 1 to it, and so it's 2. And so at that point, Chen is 2. And so you can see how you can both extend the dictionary by encountering a new name, or adding when you see a name that you've already seen before. The problem with dictionaries is, like everything in Python, there are rules about what you can and can't do. And one of the, I think, kind of frustrating things about dictionaries is that you can't just look for a key that doesn't exist. So this is a fresh, brand new dictionary. We do a constructor there, and we print out some CSEV, and boom, it blows up. And that's bad. But we can solve this by the in operator. The in operator we've used in the for loops, we've used it in lists, we've used it in strings. So that is a question. It's saying, is CSEV in CCC? Well, this is this empty one, and so it is, no, it is not. CSEV is not in CCC. Gotcha. And so using this in operator, we can avoid the traceback. We can say, if it's not there, put it in. If it is there, add 1 to it. And that leads us to this bit of code, okay? And that is the kind of code that we're going to build a histogram. This is going to histogram code.
Wait, we even look at this yet? Oh, what will the following code print? Counts equals a dictionary of Quincy 1, M. Rugesh 42, Bo 100, and 0, 10. Print counts.get Chris 0. I'm assuming we'll return error because we don't have a Chris. We do not have a Chris key in here. So this will return an error, just like...
Okay, and so this is going to have name as our iterator names. Sorry, I made them singular and plural. That's nice, but so name is going to be sent. Now, normally we'll be reading this from a file, but for now, we'll keep it easy. We're going to go through this. And we're going to have counts as our dictionary. So that starts out empty, and we're going to do a simple if then else every time through the loop. If the name we're looking at is not in the dictionary already as the key, then set it to be 1. If it's not, go get the old value, count sub name, and then add 1 to it and stick it back in. So this line right here is new, adding a new thing, and this line right here is adding some things to existing things. And you do this long enough, you start with an empty one, and you do this long enough, at the very end, it will print out the histogram that you're looking for, the histogram you're looking for. And so you say, oh, we've seen CSEV twice, gen once, and gen twice. And so that's the idea. And so this can run 1,000,000 times if you want. Now, this notion of checking to see if a key exists and doing one thing if it doesn't exist and doing another thing if it does exist is...
Pattern of checking to see if a key is already in a dictionary and assuming a default value if the key is not there is so common that there is a method called get that does this for us.
Such a common practice that the dictionary object has this method called get that collapses these 4 lines into 1 line. And so the idea is you're going to do one thing if it's in there and you're going to retrieve the current thing. Otherwise, you're going to pick a default value. In this case, we'll pick 1. Pick 0. This is like the default, right? Meaning what is not there. And if you say counts, now counts is a dictionary. .get, that's like string.upper, that's a method. You give it a key and then a default. And if the key exists, you get back what's in the key. If the key doesn't exist, okay? And with no traceback, this works.
So then in this case, we get 0.
So the best way to think about this is those 4.
So is get our way to have no traceback? I think that's what he's saying right here. Default value if key does not exist and no traceback.
Lines are equal to that 1 line because x is either going to be whatever was in there before if it exists or it's going to be 0. Now, the nice thing about 0 is the next thing we're going to do is we're going to add 1 to it. So that's going to get us to 1. So collapsing that loop that we saw before, we can make it just a 1-line loop. And this will become an idiom. This will become something that you will get used to and you will use over and over again. And after a while, right now you're looking at it, boy, that's a lot of syntax and semicolon, whatever. After a while, you just type this and not even think about it. It's an idiom. It's basically included in this idiom is how to both create new entries in dictionaries and update existing entries by adding 1 to them. So everything else in this is the same. Name is going to go through these 5 values. And we're going to say count sub name equals counts.get name, comma 0 plus 1. And so if, for example, this already has a 1 in it, then this is going to be 1 plus 1 becomes 2. If it's not, it's going to be 0 plus 1 equals 2. And so this is the idea of if new, set it to 1, not 0, set it to 1. Because the first time you see something, the count should be 1, not 0. So that's why we make this default. Now the get can be used for anything. It just so happens that 0 is a common default because it's really common that we're using this to basically make a histogram, right? A little histogram of A, B, C, right? And so you need to be in it, but then the histogram has to start at 1. So that's basically the simplified counting with get. And there's a lot of things that we're going to do inside of Python that do have to do with frequencies and how many times certain things happened. And this pattern is a really good pattern to absolutely know.
Very cool. Okay, so then, like he said, we're looking with .get, we're looking to see if this key exists. If it doesn't, our default value is 0. And so Chris does not exist in this dictionary. And so what we're going to be returned is a 0. But the nice thing is we will not get a trace back. Very cool. So we're 41% complete. This definitely is not 300 hours. We could get this done in less than 300 hours. Almost halfway done.